science, not being reified, the method thereof, when applied, is also dealing with. Cause and effect relationships in our physical and natural world, naturally observed phenomena. And that powerful tool of empiricism has been used against us to claim we're on a ball when they say science says, or my paper, my peer review, my man in white coat. And none of those things are science. What is science if A, then B, or if A, not B, actualized by varying A to see if it caused B? That's a scientific prediction and experiment in one breath. It's very basic. That's why we're using boiling water, because everybody knows you have to apply heat as the cause. Proven when you apply it and water boils.
Using the boiled off steam rather than the boiling water itself seemed to eliminate most of the intractable variations in the temperature. Interesting that, isn't it? But when we take it away from the vessel with the variations in and just go to the point of just pure water, just the water vapor, all of those variations disappear. So I'll just read the final quote from them. The heat of the steam therefore appears to be not sensibly different in different parts of the same pot. Neither does there appear to be any sensible difference in its heat, whether the water boils fast or slow, whether there be a greater or less depth of water in the pot, or whether there be a greater or less distance between the surface of the water and the top of the pot. So that the height of the thermometer tried in steam in vessels properly closed seems to be scarcely sensibly affected by the different manner of trying the experiment. The recommendation to use steam came most strongly from Cavendish, who had already made the same proposal in his review of the instrument used to the Royal Society. I'll leave it at that.
Wow. Fascinating. So,
go on, Owen.
Yeah, it is a complicated thing, right? To me, what I learned at a very young age is that the evaporation due to heat of water actually starts before 100 degrees, I think around like somewhere in the 80s. And the thing is, though, that what I learned is that even if you then introduce more heat, all that happens is just that the like more than 100 degrees, the water will just evaporate quicker, but effectively it will stay around 100 degrees.
Okay.
Right? But this is interesting about the steam.
Thank you,
called the latent heat of vaporization, and you will get water. So water molecules will share that latent heat with each other, which is why even at room temperature, water will evaporate off.
Okay.
When you boil
very slowly.
However,
yeah,
the assertion of methodology dumbed down with an explanation of water boiling as a phenomena isn't the question. What point in temperature does water boil? The question is, what causes water to boil? That's the question. So while we are using a dumbed down explanation to simplify the methodology that establishes in the hypothesis, if A, the cause that you assume will cause your effect you are studying, then B, the effect you are studying, and the contrapositive, which is if A, your presumed cause of the thing you are studying, then not B, not the effect induced by you varying your presumed cause. That's a hypothesis. If A, then B, and if A, not B. Now, this is what the philosophers of science came up with to form empiricism upon variation of A. In this case, heat. So we established that with the application of our presumed cause of the effect we are studying, the effect being water boiling, not what temperature water boils at, why does it boil? Well, in the hypothesis, you have a presumed cause of that effect. That's an independent variable, A, in my example and logic. A is heat. If A, that's if heat, then B, that's water boiling, is your alternative scientific prediction, otherwise known as a hypothesis, which also has alongside it the contrapositive known as a null. If A, my presumed cause of the effect we are studying, that's heat, then not B, not water boiling. Now, upon variation of A, that's application of heat to water, then you will either cause water to boil, in which case you have validated your alternative hypothesis, you have proven it, or you apply heat if A and water does not boil. So, the only things we need to know is how much heat. Well, you can give that in a control sense, because everything that's not being varied, that's heat. Not trying to ascertain what temperature. The arbitrary mathematical scale we assign isn't what we're concerned with. It's the cause. So
Well,
cause
I think it's
is what we're trying to establish. That's all we're trying to get across to Jaren, Globebusters, Bob specifically, who I've done this many years ago, and I'm having to repeat myself now. It's all we're interested in. The cause of the effect, and the effect is boiling water. Not what temperature. That's it.
With
Well,
that, just before you go, John, in all of this paper, that established scientific fact is a given and implicit in what they do and test here within all of these things. And none of the things that they're testing do they try to make water boil without the use of heat. In every instance, it's given and accepted that to make the water boil, we're going to need to add heat. What they're investigating here is some of the oddities. As I've described, a lot of the oddities are coming out of the apparatus, as opposed to how to do it accurately, which is to take your measurement away from the apparatus at the same phase point. So that's just to reiterate, the fact that the reason water boils is you're adding heat is a given and implicit in all of the understanding of this document. I'm done, John.
And it's used because it's implicit. That's why it was used by me and originally by Quantum Eraser as the example. Everybody understands implicitly that the application of the causal influencer is heat. You must apply that cause to get the effect. So you can simplify that into cause, heat, effect, water boiling. Contrapositive null hypothesis being heat, if applied, won't cause water to boil. And only one of those two things can and will be demonstrated as proven, true, fact at the end of the process. You apply heat and it can only do one or the other of those two things. It can either cause it to boil, in which case you've established a cause and effect relationship. If heat, then water boiling, in the most dumbed down way we can explain science to people. Or, if heat applied, water won't boil. Now that is so dumbed down so that you can understand that at the end of that process, something's getting proven. Because that's what the scientific method offers. Proof. In either instance, you're gonna prove one or the other. Either the water will boil when you apply heat, or it won't boil when you apply heat. Once you establish that you apply heat and it boils, you know that the causal influencer is heat. Now, if you remove that causal influencer and start fiddling with bowls, the water won't boil. Because a scientifically proven fact is that water needs heat applied for it to boil in nature. For all of you clowns that want to tell me about the pressure differential, you show me where some sort of pressure difference is causing water to boil in nature. Because that's exclusively what science is interested in. the naturally observed phenomena that we experience in our physical world. That's exclusively what we're interested in here at Flat Earth Debate. The natural world. Because that's what we've been lied to about. And you know what? Science is exclusively interested in just that. So that's my interest. I'm only interested in the physical and natural world, and that's all that science, not being reified, the method thereof when applied, is also dealing with. Cause and effect relationships in our physical and natural world, naturally observed phenomena. And that powerful tool of empiricism has been used against us to claim we're on a ball when they say science says, or my paper, my peer review, my man in white coat. And none of those things are science. What is science if A, then B, or if A, not B, actualized by varying A to see if it caused B? That's a scientific prediction and experiment in one breath. It's very basic. That's why we're using boiling water, because everybody knows you have to apply heat as the cause. Proven when you apply it and water boils. Disproving the null that application of heat doesn't cause water to boil. One or other's going to be proven, and is when you apply heat to water. So what do we get from the clown shows that have used the same exact magic trick on you, the flat earthers watching? Well, what do we get? We get science doesn't prove anything. Yeah, it bloody does. What? We're going to talk about the temperature of where water boils, if and only if heat's applied. Because that's how it's boiling in nature if you're studying it. And that's what we're interested in, nature, our world. Because that's what we do here. We don't go around punting new age crap about stuff we can't prove that's non-manifest. That's not our bag. That's the bag of clown shows. We're not that. Anybody got anything else to add?
Yeah, the thing is Jaron introduced the red herring to the point, but you went back to the point just then, and you're not wrong to do. But the red herring itself, as Adam shown, is incorrect, because as he went through all the variations, what the definition of boiling is vapor pressure. It's dealing with a phase change. And that phase change to a vapor pressure is exclusively measured at 100 degrees Celsius.